Developers love the Gilded Rose Refactoring Kata. In a previous video, I explained all about this kata and what makes it so special. And in this one, I'm going to show you a demo of one approach to solving it. Because I think it's fascinating how a few simple refactoring techniques can completely transform this bad design in quite a short amount of time. Hi, I'm Emily Bache. I'm a software developer, creator of Saman Coaching, and I maintain the Gilded Rose Refactoring Kata. On my channel, I have content for developers and technical coaches, and if you like what you see here, please hit subscribe and like. You can also support me and all of my code katas via Patreon, and I'd appreciate if you could do that. Gilded Rose is a refactoring kata, and that means it's a small exercise that you can use to practice techniques that make the code easier to understand and cheaper to modify without changing the overall functionality and behavior. Refactoring can be such a fun activity. It is so satisfying to turn horrible code into something that is ordered and well-designed and easy to understand. In my everyday as a professional developer, I find that these same skills that I can practice on a fun code kata will help me to do my job better. I can do my job more efficiently and I can produce better designs. In most refactoring katas, you not only get to practice refactoring, but you also have the option of exploring legacy code testing techniques, since it's always better to refactor with a safety net of tests that will catch any mistakes you make. With Gilded Rose, there are many language translations, and all of them come with a single failing unit test that you can fix and then build on further to build more tests so you come up with your own test safety net, if that's the part you want to practice. But most of the Gilded Rose translations also have an option to skip that part, and you can instead use the approval tests that I wrote for it. If there is a fixture or a test rig for TextTest in the translation, then the test is already there. You just have to work out how to run it. And that's the first thing I'm going to show you in this demo. When you open the Gilded Rose Refactoring Kata on GitHub, you see this page, and there are a lot of different folders here, and each one is for a language version of this exercise. It's been translated into many languages. But what most people miss is that one of these folders actually is not a language version. The TextTests folder contains a text-based approval test that I've written that covers the functionality of Gilded Rose pretty well and works against almost all the different language versions. It's all using this tool TextTest that my husband Jeff invented and I've been using and contributing to for many years. There's some information about it on its website, but what you really need to know is how you can configure the language version that you want to test and then run the text test for it. So I've done some bit of work on this lately to make it easier because historically it hasn't been very well documented. But I'm just going to show you here. This is the Typescript version. I've opened it up in my IDE WebStorm, and it has a README file in this folder that explains about how to run things in TypeScript, how to install things, how to run the unit tests, and how to run the text test fixture. So before we look more closely at that, let's just have another look at what's in the text test folder here. We've got a folder underneath here which is called 30 days, and that is the test case. It's called 30 days. And in here, you've got several files which are supposed to be the reference versions of the standard error and standard output that you get. So the standard output that we're expecting from the text test fixture looks like this. And it runs, for this set of items, it runs the update quality method for 30 days worth of updates and prints out the state of all the items for each day. So if you can make your text test fixture from your program produce output that looks like that, the test will pass. So here in the TypeScript version, I can just run this on the command line, and I can see output that looks kind of promising. That's what my text test will be expecting, that kind of thing. And then I just need to get TextTest to run it as a test. So there is more information, of course, in the README file under the TextTest folder. But the basic idea is that you need to go into this configuration file and tell it which language version you're testing. So in here, is that configuration file, and you need to find the entry for your language, so TypeScript in this case, and then we can uncomment these 2 lines. And then hopefully we'll be able to actually run this test. So the test is not run from the language folder. You need to go up to the main root folder of the Gilded Rose Refactoring Kata. And then there is a convenience script called start TextTest. And there's a bat file for Windows if you're on Windows. And this will do the work of installing TextTest if you haven't got it. It's as a Python package, so you need to have Python before it will work. But that's it. It's run the test and it says that it succeeded, which is a good sign. I'll just show you the same thing now in Java. So here is the same thing. I've opened up Java in IntelliJ and the same folder, the Java folder. The README file explains how to run the TextTest fixture from the command line. So let's just do that because, I mean, TextTest has no chance of running your test if you can't run it yourself on the command line. So let's try that out. So this is using Gradle under the hood to actually run my Java program. And yeah, that output looks kind of familiar. So now I need to get TextTest to run it. So going up to the main folder and running the start TextTest file. But before I do that, I need to configure it to run the Java version instead of the TypeScript version. Comment out the TypeScript version and bring in the Java version. And then when I run start TextTest, it looks pretty much the same. It says the test succeeded. So passing tests are very boring and it would be nice to know that it really is testing the code I'm about to edit. So here's the Gilded Rose code in Java. I'm going to deliberately introduce a bug and then I'm going to see whether my test fails. Yes, so this time it says it's failed and it's asking me, do you want to view the details, approve the result or continue? And I'm fairly sure I don't want to approve because this was a bug I just introduced. So I'll press V for view, and then it shows me on the command line a kind of a diff of what's happened, but that's a bit hard to read. But so it also pops up this diff window if you've configured it correctly. And so you can actually review what all the differences are. And for this exercise, it's not really much use. If you get a diff, then you've done something wrong with your refactoring and you should just revert it and go back to the last time when you knew that the tests were passing. The diff is really useful when you're doing approval testing and you need to actually understand the diff. Once you've got your safety net of tests in place, the next part of a refactoring kata is to identify design problems and start to address them. So often the first thing I spot is some kind of code smell that usually has a corresponding refactoring that I can try. There are several code smells in the Gilded Rose Refactoring Kata, and I'm going to explain how I identify and try out the fixes for them. When I come to a new piece of code like this that I haven't worked with before, and I probably need to refactor, the first code reading technique I usually use is the slow scroll. I just slowly scroll through the whole piece of code, and at this point I'm not really reading the lines, I'm just looking at the shape of the code, the colours and the shape. And this gives me a chance to just very quickly pattern match against some code smells that I know are very visual. And I've spotted a couple of things already. So one is that my IDE is kind of highlighting some things that it really wants me to look at. So I'll look at them first. So the IDE is suggesting I could replace this with an enhanced for loop. Now that looks attractive. The little preview there looks much cleaner than what I've got. So just looking at what I've got these items I all over the place, and the thing that it's going to do for me will basically remove that, and so it's all just referring to item without the I. And that looks much nicer. So I'm going to commit that straight away. It's always good to make regular commits while you're refactoring so that you can always go back if you make a mistake. Okay, so the next thing I noticed was the second thing my IDE was highlighting for me. This bit of code is a bit ridiculous. That should just be a 0, and it's saying I could fix that for you. So yeah, do that. Cool. Just run the tests. It really doesn't take long to run the tests. I can do it often, anytime I think I've changed something that probably couldn't have broken anything, but it's always good to be safe. Okay, so then the other things I noticed when I was doing my slow scroll were that we've got a long method. It doesn't all fit on the screen. And it's heavily indented. It's a bumpy road smell. It's deeply nested. And so when I've got that situation, the next thing I need to do is, well, what is all this complexity? What is this conditional? So the next code reading technique that I like to use is code folding. So I'm just going to ask my IDE to collapse all of this code so that I can just expand it one level at a time. And when I expand the top level, I can see it's a for loop. The entire function is a for loop over the item. So all of that complexity of all that conditional is inside that for loop, that bumpy road. So let's look a bit more closely. I'm going to expand the code again so I can look more closely at this loop variable. What is it doing with the item? Because this is a void function, a method, so probably it must be updating that item as what it's doing. I mean, that would be a reasonable assumption. Let's see if that's true. So expanding all the code again. So now I've got the cursor on the item instance in the loop. It highlights for me all the places I use item, not only in the code, but also in the sidebar on the right, all those little stripes, show me all the places it's using item. And it is a lot of places. There is some serious feature envy going on here. That's another code smell. The item is having its attributes accessed all over the place. So it says to me that this code doesn't belong here. It belongs on item. So the next refactoring I'm going to do is extract method and move method to the item class. Then there's the actual refactoring part, the fun part, where you're doing a sequence of moves, safe steps, making as good use of your tool support as you possibly can to improve the design. And I don't know about you, but I seem to always be discovering new things that my tools can do that make refactoring safer and faster. And I'm going to show you what I found so far, because I think you'll come away inspired to make better use of your tools too. I'm going to actually speed it up here and just show you the essential parts. First, I do extract method. Then I need to move the method. It's extracted a static method, which is very easy to move. And then when I've got it on the right class here, I can very easily change it from being a static method back to an instance method. So I run my tests. Everything still seems to be working. So another good moment for a commit. Great. So now I've got this method here. Let's go back to examining more closely this bumpy road smell. So again, I'm collapsing the code and then just expanding one level so I could see from the top, what is this thing doing? So it looks like there are 3 parts to the update item method. And one of the refactorings I might be considering here is extracting each one of those parts to its own method. But before I do that, I'm just going to look a little more closely at this. What is each part doing? Now, there's a lot of code here in the first part. That else clause and that if clause have got quite a lot going on. This middle part, though, is much shorter. And actually, I think I know what that does. It's updating selin if it's not sulfurous. So I could extract and name that part. Maybe let's just have another look and see what the third part is doing. Yeah, there's a lot of code there as well. But just looking at this, I can see some duplication. It's checking the name aged brie again and the backstage pass name again. And that is another code smell. That's telling me that I've got a repeated conditional. And that smell is telling me that these 2 pieces of code actually are linked because they're checking the same thing. So the next refactoring I want to do is extract that thing as a variable. And I wouldn't be able to do that if this name was being updated between the 2 places it's being checked. But actually it's not, so I can do this. So but that is one thing to watch out for with this particular refactoring. So there we go, I've extracted a variable for that. And now I think what I want to do is apply the lift up conditional so that conditional is only in one place, because I think that would simplify this logic. But before I do that, let's just make sure we've got a commit. So we've got a checkpoint if we need to come back here. Okay, so the steps of the lift up conditional refactoring are basically you need to extract a method that contains all of the code with the duplicated conditional. And I'll just call that foobar because it's not going to live very long. And it's kind of convenient that the argument to that is the conditional we're trying to lift up. Then I'm going to create a new conditional with two halves, an if-else statement, and put the conditional I'm trying to lift up at the top in the top level if there, and call my function in both halves of the if-else. So that's a pure refactoring. It does exactly the same as before, but it gives me also the opportunity. I know that in this first half is aged brie is true, and in the second half it's false. And now, this is where the really clever bit comes in. I can get my tool to inline these methods for me, and IntelliJ is pretty good at this, actually. I was surprised when I did this earlier. It sorts out all of the places where it knows that aged brie is true, where I've replaced it with true, and just got rid of them. So it's simplified the code for me already. I've kind of duplicated the code, but got rid of some of the redundancy, and the aged brie conditional is only in one place now. Great. So I'm not quite done yet. There's a bit more cleanup, but let's just run the tests and make a commit so that we've got a checkpoint. Yeah, so I've got these things that my IDE is highlighting for me. Look, we know that this is not called backstage pass because we know it is called aged brie, and it can analyze the code and fix this for me. So let's just take its advice. This one, I just wanted to show that you don't have to believe it. It will actually explain to you why it thinks it could remove this line of code. And it's saying, well, you know, there's a hard-coded contract here. It's known that the item name is equal to that, so it can do this. I'm quite impressed with my tool here. And I think this is kind of new feature. I haven't seen it do this before. So anyway, as I said, I learn new stuff about my tools when I do code katas. So I've taken all my IDE's advice. The tests are still running. Let's see what's next. Oh yeah, make a commit. Just make sure I've got that checkpoint. So now I've lifted up the is aged brie conditional, but I've still got this is backstage passes in several places. So let's do the same treatment for that. That code is repeated. So let's extract it to a variable. Is backstage pass. I'll just move it up to the top there. So this is going to be the same procedure. I've got this is backstage pass conditional in more than one place in this part of the code. Let me just find both the places. Yeah, there they are. Folding up the code really helps me to get an overview of what's going on here when there's so much indented code. So this is the part that I need to extract as a method. And again, foobar, it's going to be inlined again very soon, so it doesn't really need a name. But I can surround this with the if-else statement, put the condition I'm trying to lift up right at the top, duplicate the method, replace the first one with it's true, and the second one with it's false, and then inline. Excellent. And it's done quite a lot of work for me there. I'm just going to merge that if-else because that makes it less indented. And then I can just check, yeah, is backstage pass is just at the top now. It's nowhere else. It's done the right thing. The tests are passing. Let's just deal with that IDE warning there. So the tests are still passing. Make a commit. Then there's just one left. This is name is sulfurous hand of Ragnaros is also in several places. So same treatment, we're going to extract it to a variable is sulfurous. We're going to put that at the top with the others. We're going to just check our tests are okay. Yep. And commit for a checkpoint. Then we've got this is the code that's using the is sulfurous that I want to extract to a method. Foobar. Surround that with the if-else. Same treatment. In the first half, this one is true, and in the second half, it's false. Inline. Great. And then I've got the IDE warnings here, but just check the tests. Yeah, tests are okay. deal with the IDE warnings. Oh, I can remove quite a lot of stuff here. Yeah, actually, so that's one of the really fun things about this exercise. Sulfurous doesn't do anything. And it's really hard to see that from the original code, but once you've done this lift up conditional, it's just like, oh, yeah, it doesn't do anything. So that's kind of cool. So let's just merge that if else so that the top level structure of this function is kind of clear. It's a series of if statements looking at, is it an aged breathe? Then I do this. Is it a backstage pass? Then I do that. Is it sulfurous? I do this other thing. And at this point, I'm feeling, I've kind of got this under control. I kind of know what's going on. I've dealt with most of that bumpy road problem and that there's a really clear structure. So, I mean, there's more I can do here. There's definitely more I can do here. I could probably extract a method for each type of item and but I'm going to leave it here for the moment. I think I've shown you the main parts of the refactoring. I hope you agree. The code is looking much better now I've refactored it. I've done this Gilded Rose Refactoring Kata many times, and I do learn more each time I do it. I've managed to show you several techniques today. Using an approval test set up with a test rig and a TextTest runner. Identifying and investigating code smells. Moving in tiny steps and making sure the tests run and pass after each small step. And then the refactoring sequence to achieve lift up conditional. I do encourage you to have a go at this exercise yourself and train your refactoring skills. If you need any more encouragement, do take a look at my previous video, Why Developers Love the Gilded Rose Kata. Happy coding!